Good afternoon, students. Today we will see about chelates and chelating ligands. What is chelating effect? When a bidentate or polydentate ligand is attached through the two or more donor atoms to the same central metal atom, is forming a ring structure. See here, copper is the central metal atom. Two bidentate ligand is attached to the copper, so it creates a ring like structure. So this structure is called as chelating compound, and the ligand is said to be chelating ligand. And because of this ring structure, the central metal atom and the coordination complex become more stable. That is, the bond breaking will not be taken place easily. This is said to be chelating effect. Okay, we will go, these are all the things what we are going to discuss now. So what is the example, what are the example for bidentate ligand? When two donor atoms is attached to the central metal atom, it is said to be bidentate ligand. For example, oxalate ion and ethylene diamine. Here NH2 CH2 CH2 NH2 twice, ethylene diamine. Its short form is EN. That's why I mentioned here EN. And more than this, we have tridentate ligand, tetradentate ligand, pentadentate ligand, hexadentate ligand. So among the polydentate ligand, the most preferable hexadentate ligand is EDTA. So I have mentioned here. Here I mentioned 6. Why? Because it is a hexadentate ligand. Already we have seen this its structure in classification of ligands. Okay, this is what I am trying to say. When bidentate or polydentate ligand is attached to the central metal atom, it forms a ring like structure and make the complexes more stable. That's why the effect is called chelating effect, and the ligand which is used to make the complex is said to be chelating ligand. Okay, for example, here I have given in detail, that is, when a bidentate ligand such ethylene diamine coordinates through both the nitrogen atom. If you are considering this ethylene diamine, this nitrogen and this nitrogen donates the paired electron to central metal atom. When you are comparing this ethylene diamine, again these two nitrogen atoms donate the paired electron to central metal atom. That's why we are mentioning the arrow like this. This nitrogen donates the paired electron to the central metal atom. Okay, and results in the formation of ring structure. So it is called chelating ligand. What is the complex ion? This ethylene diamine. Here the ligand itself has 2 as the subscript. So while we are naming, we should write bis instead of, here the ligand itself has 2. It should be pronounced as di. So in the name itself, ligand name itself has ethylene diamine. So while we are naming the compound, what we should use? Bis ethylene diamine. Copper ion is expressed in here over the coordination pair. So bis ethylene diamine copper 2 ion, we should name like that. Okay, and thus it is called a chelate ion. Okay, here ethylene diamine structure in simple form is written like this, and those who feel hard to understand the structure, see here NH2 CH2, CH2, NH2. The same thing what we have written here, we are writing in the form of ring structure. Again one more molecule. Okay. And here metal ion, that is when we place the metal ion, these two nitrogen atom from one ethylene diamine molecule donates the paired electron to the central metal atom. So if again one more ethylene diamine is attached to the metal, means we will have the structure like this. Okay. And in similar way, trident ligand is that. One more example is given. um, Trioxalato ion 3 ion. Okay, here oxalate anion acts as the chelating ligand. You know, COO minus COO minus, it can be write like this also. Okay, so when ion is bonded with 3 oxalate ion, you will have a ring like structure like this. So one oxalate ion and second one, third one, it is in octahedral structure. This one is square planar structure. Okay, and some neutral chelates also possible. For example, nickel DMG twice and iron acetyl acetinoto ion. Okay, next, the chelating ligands are used to be more stable than the ordinary unidentate ligands, and that's why this effect is termed as chelating effect. See here, bis ethylene diamine cadmium 2 ion can be written like this also. Here I am using CH2 NH2 4 times because ethylene diamine has NH2 CH2 CH2 NH2 twice. So instead of writing 2 times, I am writing CH2 NH2 4 times. See here, CH2 NH2 4 times means what you will have, CH2 NH2 CH2 NH2 twice means you will get 4 times, and if you are writing again means twice CH2 NH2 NH2 twice, so 4 times. That's why I am showing like this also. Better you follow this form and this form. This will be most commonly crossing the writing pattern. Okay, we will next see the continue with isomerism exhibited in coordination complexes.